All right, question 1 has, we did this in class, but I'll recap it here. Movie stunt driver on a motorcycle speeds horizontally off a 50-meter high cliff. So here's our cliff, it's 50 meters tall. Let's see. And we want to know how fast does it have to be going. So we're looking for the velocity v for it to land 90 meters away from where it started, where the movie cameras are. All right, we're going to ignore air resistance, like we've been saying we're going to do, because it's negligible. It might affect the results a small amount, but very little. Okay, so we are going to break this up into, oops, my battery's dying. We are going to break this up into the vertical and the horizontal components. So when we do that, we get vertical and horizontal. And they're connected because it is one object. It's not like there's two objects here. So they're connected. But what I'm going to do is start by listing out my variables. So delta y, delta t. I'm using the y just to really distinguish it from, from the x. So that's a y, and then a. And then over here we have delta x, delta t, and then it's vx. And if you'll recall, the reason I have 5 variables on the vertical side and 3 on the horizontal side is because vertically we know that the acceleration is the acceleration due to gravity, which is 9.8 meters per second squared down, right? And I can draw that here. There's my g, and it's down. And horizontally, a equals 0, which means v is a constant, right? So v is a constant, and we're not going to have to worry about acceleration in the horizontal direction. So what do we know? Well, we've got a whole bunch of information, and we have information we want. So first thing you'll notice is that the question tells us that the motorcycle speeds horizontally off of the cliff. So in that case, we know that our initial vertical velocity, so our initial component of velocity in the vertical direction, is 0. And this is the thing that I'm asked for. This is what I'm interested in, because it says what velocity, how fast, it basically says how fast must he leave. So his initial velocity is what we want. We know his initial velocity is horizontal, so it's just Vx that we're looking for. Other things that we know the horizontal distance, how far it goes, is 90 meters. We know the vertical distance that it drops is 50 meters. We know the acceleration is 9.8 meters per second squared. You'll notice what I did here. I made everything positive. So in this problem, the motorcycle ends up down, like it lands 50 meters below where it started. Acceleration due to gravity is down. So everything is generally down. There's no up. So in this case, it's a lot easier just to make down positive and up negative, because there is no negative. So that makes the displacement of 50 meters down, and it makes the acceleration due to gravity down also. All right, so now the thing that we know is that the time for the two are the same, right? It's just one object. It's just the motorcycle. So there's not 2 times. Whatever the time is for one is the time for the other. Since there's 5 variables on the vertical, we need 3 variables to be able to solve it. I have them, the y, the v naught y, and the a. So I don't know, and I don't care what the vertical final velocity is. This is my don't know, don't care. And kind of that's what that is like, with what speed does it kind of land right at the bottom? What speed is it going vertically at that bottom? I don't care. But I do find this information useful. If I know the time here, I can put it into the time here, and once I have that, I can solve for Vx. And that's what we're going to do. So we're going to solve that out. So what we have is, we have my don't know, don't care is v, so vy. So we're going to use delta y, delta y equals vo delta t plus 1/2 a delta t squared. All this goes to 0 because v naught is 0. So then rearranging this to solve for delta t, let's do it in the same color. rearranging this, I get delta t equals 2 delta y over a, and then I'll take the square root of all that. So plugging in the numbers now, I get 2 times 50 divided by 9.8, and this works out to about delta t equals 3.194 seconds. Okay, so then plugging that into here, I get this time is 3.194 seconds. So now my unknown is really Vx, and I can see, because the velocity is constant, this is important, but because the velocity is constant, then I can use the equation Vx equals delta x over delta t, right? Because the average velocity is the velocity. There is no change in velocity. So then Vx equals 90 divided by 3.194. This is meters. This is second. So my answer works out to about, when you round, 28 meters per second. All right, and that's the answer we're looking for. They're asking for the final velocity, the initial velocity. So that's what it is. There we have it.